Hello everyone, welcome to this video. In this video, we shall be looking at question number 24 from exercise 9.3. So let's have a look at the question. It says that show that the ratio of the sum of first n terms of GP to the sum of terms from n plus 1 to 2n, right? This is 1 raised to power 1 divided by r raised to power n. So what actually they are saying, we need to calculate the ratio. We need to show this ratio is equal to 1 by r raised to power n. Now ratio of what? The ratio of sum of first n terms of GP. So that means Sn, the sum up to first n terms of GP, and the sum of terms from n plus 1 to 2n. So that means if your GP is like this, a1, a2 up to so on, we have an in between, an plus 1 in between, and so on up to a2n, correct? Now they are saying we have to take the sum up to these many terms, the sum of these many terms. So you already know what is S2n, that is the sum of all the terms, right? And you know what is Sn, that is the sum of these many terms. So from all the terms, if you subtract these many terms, so you will be left with just these terms, and this is what is required. So that means if we subtract them, we would obtain the sum of all the terms starting from n plus 1 to 2n. So you can write this as the sum up to 2n terms minus the sum up to n terms, correct? So we need to show this thing in this question. So let's have a look at the solution. In order to prove that, we already know what is the formula of sum of first n terms of GP. The formula is a r raised to power n minus 1 divided by r minus 1. This formula is utilized when r is greater than 1, but in this question there is no information about r. So we can use either of the formula. We can also use this formula 1 minus r raised to power n divided by 1 minus r, where r is less than 1. Here this formula and this formula is the same, which is obtained from either formula by taking a negative sign outside, correct? Okay, so I am using this particular formula in order to solve this question. So let's take the left hand side of whatever we wanted to prove. Let's take Sn divided by S2n minus Sn, substituting the value of Sn here, right, and here, and substituting the value of S2n here, correct, and then simplifying the terms. Here you see you can take the LCM of these two terms. It would be r minus 1, and this r minus 1 would cancel with this r minus 1. So you would be left with these terms. Next you can take a common from the denominator so that it would get cancelled with the 1 with numerator, correct? So you would be left with r to the power n minus 1 divided by r raised to power 2n minus 1 minus r raised to power n minus would become plus 1, correct? This minus 1 and plus 1 would be cancelled, so you would be left with the numerator would be as such, right? And you would be left with r raised to power 2n minus r raised to power n, this term. Now from the denominator you can take r raised to power n as common, because the first term could be written as r raised to power n into r raised to power n. So you can take this r raised to power n as common, so you'd be left with r raised to power n minus 1, right? This is what you would be left with. So you see this term and this terms cancels with each other, so we have the final ratio as 1 divided by r raised to power n, right, which is nothing but your right hand side. So in this case the left hand side becomes equal to right hand side, and this is what we wanted to prove here in this question. So I hope you understood this question well. That is it for this video. Thank you for watching.